On to the second part of learning target number 5. We observed and derived information from a Fourier analysis of waves, and now we're going to do something similar with an oscilloscope. Okay, and so from an oscilloscope, the way that it works is there's a knob that will tell us the time base, okay, and then per division, okay, or derivation, and that is the space in between each component in the x direction or in the y direction, right? Each square, the distance between each square. And then we'll have the voltage. Okay, so first thing I want you to note, the time-based component is the x direction, and the voltage component is the y direction. Okay. And what we see here, it tells us voltage is in the y against the time, which is in the x. And then it's marked out depending on where the knobs are set to, will determine the amount of voltage or time per centimeter or square on there. Okay, so let's look at this for a moment. Remember that the period is the amount of time between waves. Okay, so if I want to know, without knowing what the knob is set at, okay, and so we have, that one's milliseconds. Let's make it as simple as, usually we see microseconds. Let's do 1 microsecond. So let's say this knob is telling us that each division here, each square, is representing, set at 1 microsecond. Okay. And so when that's the case, and we want to know the period, that's the time between waves. Okay, so let's find a complete wavelength. From peak to peak or trough to trough is usually the easiest to identify. And so now I'm going to go from peak to peak, and I'm just going to count that out. I'm moving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 divisions, okay? And each division is 1 microsecond. So if I have 1 microsecond per 1 division, and I have 12 divisions, then I am left with 12 microseconds for my period, okay, the time between waves. And then from here, usually what the question asks something like find the peak or find the peak to peak. So peak is just amplitude, right? So if we find, that center line of our wave there, and then it'd be distance from the center up to the peak. I think it's easier with these because sometimes it's hard to define right where the middle is. I think it's easier to find the peak to peak first. It's easy to go, okay, here's the location of a peak, there's the location of a trough, right? And let's say that each one of these divisions that this knob is set at, each division is going to represent 5 volts, okay? So we have how many divisions from peak to peak? So it'd be 1, 2, 3, 4, 5, 6, 7, 8.5, right? Kind of like right in the middle there. So if we have 8.5 divisions, and we know that 5 volts is equal to 1 division. 16, what's that? 13. So we'll do 5. 5 multiplied by 8.5. 42.5 volts, and this is a peak to peak, okay, peak to peak voltage. And so if we want to know just the peak, that would be the amplitude instead of 2 amplitudes, so we just divide that by 2. Okay. So for my peak, I would take 42.5 volts divided by 2, and that gives me 21.25 volts for my peak value. Okay, now the last part of this, we know volts, we know period, right? And so we can figure out what frequency from the period, okay? And so we have period is equal to 1 over frequency. So we know this, we're going to solve for that. Now I want to get this on the top of my fraction, so I'll multiply both sides by frequency. So if we do frequency times by period, that'll give us 1. We'll divide by period, so frequency equals 1 over the period. So I'm going to do 1 divided by that 12 microseconds there. And reminder, micro times 10 to the negative 6. Let's see. Let's double check. One second. I don't want to tell you wrong. Let me check if I had it right. So micro is times 10 to the negative 6. So it'd be 1 divided by 12 times by 10 to the negative 6 seconds. Okay, and so that gives us a frequency of 0.08331 over seconds, or hertz, right? Means the same thing. Okay, an antinode is exactly that. It's an area of maximum amplitude. So when I look at this image here, right in the middle, that's our node. Okay, so our antinodes are our peaks and our troughs. Okay, example problem. Oh, this image is small. Let me look at it and see where this is set at. Okay, so the bottom one, the volts, one division is set at 2 volts. So 2 volts for every 1 division. And then the other one, yeah, I think it's 20. Okay, so that's my voltage, and then I think, if I'm reading that right, I think we're getting 20 microseconds per 1 division on the time. Okay, let's see where we're at time-wise. Okay, so find the peak to peak period. Let's do peak to peak first. Peak to peak. Okay, so reminder, it's peak to peak, right? So when I look at this image, there's that one. So there's 1, 2, 3, 4, 5 divisions there. Okay, so if I have 5 divisions, and this is the x component, so it's the voltage one, and I multiply that by 2 volts for every 1 division, that would give me 10 volts. Okay, and so if that's 10 volts, then my peak value would be half of that, right? It'd be from the middle up or the middle down, and so it'd be 10 volts divided by 2, so it'd be 5 volts. Period is the amount of time for a wave, and the x represents the time component. So that looks like it's 1, 2, 3, 4, 5, 6, 7, 8 divisions there. Okay, so period, we have 8 divisions, and it's 20 microseconds for every division. Okay, so that would be what, 160 microseconds, which is the same as 160 times by 10 to the negative 6 seconds. And then to figure out frequency, it's going to be 1 over the period. Oh, sorry. I was just looking at this. I forgot to do the times 10 to the negative. Divided by 12 times by 10. So this is much bigger than that. This is 833 hertz. Okay, so then back to this one, I'm going to do 1 divided by 160 times by 10 to the negative 6. And that gives me a frequency of 6,250 hertz. Okay, so we found our peak to peak, we found our peak, we found our period, and our frequency. Okay, so that wraps up this unit. So next week we're going to do the review and take the exam, and I will post that review. I'll set the due date as next week, but I'll post the review in case you want to get a head start on that. Alright guys, let me know if you have any questions.